The number of combinations of atoms that can make a molecule is so vast, and what we're trying to do is pick out the most promising ones that can ultimately become medicine that will save somebody's life. I'm Richard Lonsdale. I'm a scientific leader in molecular design at GSK Stevenage. So GSK is a big international pharmaceutical company which works on finding cures to a wide variety of different illnesses. So many diseases are caused by proteins that start misbehaving, and we try and stop them from doing what they're doing by designing small molecules which fit inside those proteins, and when they bind, they stop them from doing what they do. I use state-of-the-art software including machine learning, simulations and artificial intelligence to speed up the process of delivering life-changing medicines to patients. Let's have a look at the software in action. Here is one of the molecules that we are working on which may be able to treat cancer. I'm running simulations on this molecule to see how well it binds to its site of action and how strongly. I also have a set of similar molecules where small changes have been made to the chemical structure. The simulations can show us whether the small changes will make the molecules bind more or less strongly. By making these predictions, we only need to make and test the compounds that are most likely to make it in the real world. Once we have made these predictions and identified the most promising looking compounds, we discuss them with medicinal chemists and decide on which ones to make. For me, it's really rewarding to use my chemistry background to work on these kind of problems that ultimately help make a difference to patients' lives. I first got interested in chemistry when I was studying at school. I had a really engaging teacher who led us through problems, and we came up with the ideas ourselves, and I really liked the logic behind that and not the fact that we just had to memorise lots of facts. And I knew very early on that I wanted to study chemistry at university. As part of my fourth year of my degree, I had to do a research project, and there was the opportunity to do computational chemistry. I could escape the lab but also use chemistry and computers. At the end of my PhD, I did an industrial postdoc in a different company. Through doing that, I got the experience that I needed in the sector in order to get the job that I have now. Skills that you need to be able to work collaboratively. These projects that we work on involve lots of people, and you need to be able to communicate the results to them. There's so many different aspects to developing a medicine. You're constantly learning within this job. If you're interested in working in chemistry, but you don't want to work in a lab, there are other opportunities available, such as computational chemistry, where you can really make a difference.